Okay, so I'm going to start this morning talking about probability distributions. So let's think about a football match. From the point of view of one of the teams, there are three outcomes, aren't there? You can win, you can lose, or you can draw. And each of those will have an associated probability. And it's hard to calculate, but it might be that the chance of winning is 0.3, the chance of losing 0.4, and the chance of drawing is 0.3. And hopefully you are happy with the fact that all of those have to add up to 1. So what we have there is a probability distribution. But we tend in maths to deal with numbers. So let's look at a situation which is perhaps a bit more comfortable for us. Here's a spinner. So it's one of those spinners, you spin it and it lands on one of these numbers. There are 4 sections. The possible score you can get is either 1, 2, or 3. And the score that you get on this, it's random. So let's say the score, I'm going to call it capital X. This is the notation we use. I always think it's a bit confusing, but there we go. Capital X is what we call a random variable. So it's a random variable that can either be 1, 2, or 3. And the probability that it's 1, so the probability that x equals 1, so we use this notation here, is a quarter. Notice I'm using decimals, fractions, doesn't really matter. Probability of it being 2 is a quarter, probability of it being 3 is 2 quarters, or 1/2. Now this random variable can only take certain values, 1, 2, or 3. You can't get a score of 1.5 in this game. So because of that, we actually call it a discrete random variable. You may remember from GCSE, discrete data is data that can only take certain values, like your shoe sizes or like the number of students in the class. So this is a discrete random variable. It is a quantity whose value could either be 1, 2, or 3, and it is random. Okay, and what we have here is a probability distribution showing how the probabilities of that random variable vary. Probability distribution. That probability distribution is in table form. There is one other way we can show a probability distribution, which I will show you shortly. Let's talk about a third example of a normal dice. So a normal dice, I'm not going to draw a normal dice, hopefully you can see that the normal dice, the scores it can be are... And in this case, the probability that you get each of those numbers is the same. So here we have the first special case of a probability distribution. This is a uniform probability distribution. So a uniform probability distribution is one where all of the probabilities are the same. Okay, so 3 examples of questions involving discrete random variables and probability distributions. So here's one. 3 fair coins are flipped. Write down all the possible outcomes when the 3 coins are flipped. So you can have head, 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 for example. A random variable x is defined as the number of heads when 3 coins are tossed. Write the probability distribution of x as a table and as a probability mass function. We'll ignore that for now, we'll come to that in a minute, but pause the video at this point and just see if you can do part A and B part 1. Pause and then watch on. Okay, so I'm hoping you got 8 possible combinations. Doesn't have to be in that order, but there you go, there's my 8. And then I started to set up a table. Now here's my first attempt at a table. Can you spot the mistake I made? X is this random variable defined as a number of heads. I thought, well, you could either have one head, two heads, or three heads. Actually, I forgot that you could have 0 heads. So there we go. So that was wrong. And there's my second attempt, and I worked out the probabilities. So there is one way you can get no heads, and that's tail, tail, tail. 3 ways with only one head, so that's that one, and that one, etc., etc. That is my probability distribution written as a table. So what about a probability mass function? Sounds very pompous, isn't really. Let me show you what it is, and I've prepared the answer there. So all it is a statement of the probabilities set out in a rather odd way. But can you see what it means? So the probability that x equals x, well, if it's 0 or 3, that's got a probability of 1/8. So that's those two. 1 and 2 have both got a probability of 3/8. And then important with a probability mass function, you say, right, there's no other possibilities. So everything else has a probability of 0. So we've got the possible outcomes, the number of heads in this case, and the probabilities. And so this is a probability distribution expressed in a table, and this is as a probability mass function. Okay, so here's the second worked example. Note that this time we've got a biased four-sided dice. So it's got 4 faces, 1, 2, 3, and 4, but it's not a uniform probability distribution. It's not 1/4, 1/4, 1/4, 1/4. We're told that the probability of each score is some constant k over x, which is the score itself. So that means the probability of getting 1 is k over 1. The probability of getting 2 is k over 2. The probability of getting 3 is k over 3. And the probability of getting 4 is k over 4. So I've interpreted this statement and turned it into a table. So part A, find the value of k. Remember what we know about these 4 probabilities. See if you can pause the video and have a go at that. Okay, so hopefully you realised that those 4 probabilities, k over 1, I've just written as k, have to add up to 1. And you could use your calculator at this point. I suppose I've gone old school, so I've written them all with a common denominator of 12, added them up, and that means that I know that k is 12 over 25. And that means that this probability is 12 over 25. This is 12 over 25 divided by 2. This is 12 over 25 divided by 3. And this is 12 over 25 divided by 4. So I'm going to rewrite that table. Here it is. So 12 over 25 divided by 2 is 12 over 50, or 6 over 25. 12 over 25 divided by 3 is 12 over 75, or 4 over 25. And 12 over 25 divided by 4 is 12 over 100, or 3 over 25. We're then asked, I've written them here because I can't see the original question, but we're then asked to work out these probabilities. So x can be 1, 2, 3, or 4. The probability that x is greater than 2 doesn't include 2. So it's these 2 probabilities added together. So that's 7 out of 25. The probability that x is between 1 and 4 can't be 1, can't be 4. So it's these 2. So that's 10 out of 25. And the probability that x is greater than 4 can't be greater than 4. Probability is okay. Third and final example for now. Here we've got a probability mass function, sometimes just called a probability function, and we are not given the table. And although the question doesn't ask for for a table, that's where I'm going to start with this. So I can see from here that the values that x can take are 1, 2, 3 and 4. So that's how I've set up my table. So I am now going to get you to pause the video and see if you can fill in these probabilities using this function and then work out the value of k. So there's quite a lot going on there. See how you get on. Okay, so hopefully you were able to fill in the probabilities. A little bit fiddly, but for 1 and 3, it's k times the value, so k times 1, k times 3. And for 2 and 4, it's k times 1 minus the value, so for 2, it's k times 1 minus that, so that's just 1k. And for 4, it's k times 1 minus that, so it's just 3k. And that meant that altogether you had 8k, so that k had to be 1/8, or 0.125. It doesn't really matter. I tend to work in fractions because it's a whole lot easier. And that means we can actually work out the probabilities involved, although the question just said find the value of k. And then the second part of that question, well, the probability that x is greater than 1, well, that's all of the values apart from this one, so it's 7/8. Okay, so I have attached to the homework a selection of questions in a PDF, but they're actually all from the Stats and Mechanics Year 1 book, so you'll see them on page 87 and 88. Question 6 is the one we've just done, but there's a few questions from page 87, and then there's a question from page 88. I'd like to have a go at those today, and I will post another video tomorrow. Not a great deal of extra work tomorrow, but I'll just take it one step further, and I'll also ask for you to submit a photo of one of these questions, just for reassurance that you are engaging in what we're doing. All the best. Any problems with attempting these questions, then as always, drop me an email, mcooper@ilfcombacademy.org.uk, and I trust you are all well.